All right, so people at home and people here. Yesterday, we had a hot plate, and it was plugged into the wall. We put a beaker with a bunch of ice in it, and then in that beaker, we put a thermometer hooked up to a computer that showed us the temperature, which started out around 0 degrees Celsius. All right? So everybody, what's up?
Nothing, I was trying to stop.
Oh, okay.
Emergency stop.
Yeah, it's for the gas.
Yeah.
So everybody in the class had a beaker full of ice, okay? And our temperature wasn't 0, right? It was close to 0, probably like 3 degrees, because the thermometer is really long, and it's not just measuring the tip of the thermometer. Anyway, so about 0 degrees. Then at the count of 3, everybody, boop, turn the hot plate on at the same time. Then the hot plate immediately got hot, and the temperature started going up. So we took the temperature every 30 seconds for like 13 to 15 minutes, depending on what group you were in. So we took the temperature every 30 seconds for a long time. And here is the gist of the lab. Here it is. A person would reasonably expect that if you had a bunch of ice on a hot plate and you turn the hot plate on, now there's no adjustment on the hot plate. You just turn the hot plate on and it's on wide open, right? And if you had your hand on that hot plate, I promise you, if you turned it on, you would be in seriously hurt within 3 or 4 seconds, okay? They get hot quick. So we turned it on, so we would expect, and it would be a reasonable thought for you to have, that if this was the temperature and this was the time going by, it would be reasonable for you to expect the temperature to increase regularly over the course of whatever amount of time, right? But that is absolutely not what happens, okay? And that's the point of the lab. The point of the lab is there's a lot of chemistry to this. Something as simple as that actually has a lot of chemistry to it. Our top temperature is going to be 100 degrees Celsius, all right? As time went by, when we first flicked the hot plate on, the temperature stayed very low for like 5 minutes. And then, right at the time when you looked in this beaker and all the ice was gone and you just had water, then the temperature started to shoot up like you would expect it to. And then the temperature shot up until it hit 100 degrees, and then the graph leveled back off again. Now, when you saw the graph level off, if you look back at your beaker, you would have seen bubbles. So the water was boiling. So the gist of the whole thing is melting this ice is like slow, then boop, and then slow. Why was it slow right here, Brady?
It's because it takes energy to heat it up, and it's
The
gonna
what?
heat the ice up.
Yeah, it takes energy to melt the ice. So we have melting here, okay? So it takes energy to melt the ice. And I'm going to explain this to you in a way, if you were thinking, let's say you were hired to be a secretary for a day. And you were at your desk without your mask on and you were texting people. Then the boss wouldn't want you to do that, right? I'm just joking. Now, this is really what I mean. If you're a secretary and the boss hired you to like file a bunch of papers, right? Okay? And you're filing papers. And then right in the middle of that time, the boss comes in and says, hey, Mr. Perkins, the secretary, I need you to run out to the coffee shop and get everybody some coffees. And I'm like, okay. Then I go to everybody some coffees and I come back. And then I come back and I work a little bit and the boss says, why aren't more of these papers filed? I would say, because I can't do 2 things at once. I cannot go to the store and get the coffee and file the papers at the same time. This is the same thing right here. And you may be like, what kind of scenario is this? The hot plate is dumping out heat as soon as you turn it on. And the first thing it has to do is melt the ice. Melting the ice takes energy. And then after the ice is melted, then you can see that energy on the graph. Then you can see the temperature shoot up. But the hot plate can't do two things at one time. It can either melt the ice or raise the temperature. And that's how it works, okay? Now, the energy from the hot plate is hidden from the graph here. That term is latent. Latent means hidden energy, okay? And then again up here, there is latent or hidden energy because boiling is occurring. So when you look at a graph and you see it go flat, there's generally a phase change occurring. A change from one phase to the other. And the phases we're talking about, if this graph went down here below zero, which ice can definitely be below zero, right? The phases would be solid, liquid, and then what happens if we boil all the water out of here?
Yeah.
Shoot up again as steam or gas. So going from solid to liquid is a phase change called melting. Going from liquid to a gas is a phase change called boiling. And both of those processes take energy, and they latent energy that's hidden from the graph. And that is basically the idea of this lab. Now I'm going to put up a little slideshow with some questions on it, and you should be able to answer them. Now you haven't seen all these questions before, and they're going to be worded a little bit oddly, but you should be able to figure them out. All right? All right, here we go.